Alright, so here is the information from chapter 9 or chapter 8 that you'll need. I have changed some numbers up for you and just kind of messed around with it. Now, what we should remember on multiplication, and I have not looked at these in terms of just making up the questions, so you get the real deal. I might just mess up a whole lot in this thing, we'll see. But we do remember that multiplication is the one where top meets top, bottom meets bottom, and what you can do in multiplication is cancel out anything that is common. For example, we can cross out that 3 and cross out that 6, turning this into a 2, because both of those can be divided by 3. I hope you remember that. You can also say there are 4 A's here, 3 A's here, so I'll cancel out 3 A's on both, leaving me just A up there. You also have 5 and 23 have nothing in common. B5 and B2, you can take off 2 B's, leaving B to the third, and that B goes away. And then you have 1C minus 7 here, 3C minus 7 there, which means we'll turn this into a 2 and cross that out. In the end, you simply put what's on top, so we still have a 23 and an A up top. Just be careful. Over 5 and 2 make 10. B to the third with C minus 7 squared. So again, that was your multiplication part that we learned how to do, is just again cancel out what's there and then put whatever's on top and bottom together, and that's that. Alright. We also learned that on division, remember, we don't know how to divide rational expressions, but we do know how to multiply them. So we put 5C5 D3 over 3 Q6 R4 times, and then we flip this over, 9Q8 R3 over 17 CD5. And from there again we follow what we learned to do. 5 can't cancel with 17. C, you can cross out a C and leave this as C to the fourth. There's 3 here, 5 there, so we take 3 off, leaving this as D squared, and that goes away. 9 and 3 can both be divided by 3, making this a 3. There are 8 Q's here, 6 Q's here. I had to go back to here because I write so badly, leaving us Q squared. 3 R's, 4 R's, leaving us 1 R down there. And again, just kind of check to make sure everything's where it needs to be. And again, put everything on top there, which means 3 is still there. Alphabetical, C to the fourth, Q to the second, over 17 alphabetical, so D squared R would be what you would end up with on that. So again, what we learned on that is just how to turn that into multiplication and then cancel using what we did, using what we know about the cancel, whenever you have the same thing on top and bottom. We learned to turn this into a division problem. And then we learn to turn that into a multiplication problem, because again, we don't know how to divide those things. Now, what we also talked about was that whenever you have stuff like this, let me make sure it's right, 5x minus 5x, 5x squared plus 5, 13x squared. Okay, so what we learned was that you should always try to check to see if you can factor whatever's there. And as odd as it may seem, this is actually 5x minus 1, which is what helps us out now. And this, actually, if you look at it, even though it looks like you can't factor it, x actually comes out of this to make 13x minus 7. So what I usually do is, again, I cross it out and just write whatever belongs up top of that. Now we still have the setup that we need. 5 and 5 both go away. X and x both go away. And I think that's all that we have left over. So x minus 1, 13x minus 7, x squared plus 5 would be what we end up with on that. So again, just basically making sure you understand that you are supposed to go through and turn into multiplication, cancel out what you can, and put everything together. On your addition, if you remember, again, first thing you want to do is factor these things. So this turns into, wow. I guess I would factor first because you can do an LCD. So 4 times x squared minus 9, which is 4 times x plus 3 x minus 3, whereas this turns into 2 times x plus 3. Which means, remember, we need an LCM whenever we add. We need room for 4, because 2 and 4 both meet at 4. We need room for x plus 3. We need room for x minus 3. And then from there we look and say, what is missing here? Of course, this is missing nothing because it has your 4, has your x plus 3, has your x minus 3, whereas this needs a 2, and it also needs a x minus 3. So we end up with, again, the bottom's going to stay the same, 5 plus 4 times, because I'm doing more, I'm going to use a bracket, 2 parentheses x minus 3. Yep, all over this stuff. This turns into, and I'm just going to go ahead and work that out here since I don't have a lot of room, 2x minus 6, which means that we end up with, what, 8x minus 24. Again, this is a little way that I'm using to save space. So 2x minus 3 turns into 2x minus 6. That's going to get multiplied by 4, making 8x minus 24, which means we end up with 13x minus 24 over this. Again, this is just for you to watch, or you can try it out before you resume the video, however you want to do it, but just make sure you are at least looking at it and trying to bring some of this stuff back, because again, if this is the stuff that's supposed to be on your assessment, then that means it's something that's kind of important for whenever you move on. Again, adding here, we need a least common multiple. To me, the least common multiple is 6y. Since this is 8 over 1, this is actually missing a 6y, which means that this turns into 48y plus 5x over 6y. Again, 6y is missing from this, and nothing is missing from that because it matches. 6y times 8 turns to 48y, 5x comes down, LCM comes down as 1. There's your answer. On this one, your least common multiple, again, we need it because we're subtracting. We need an 8, we need room for 2 x's, and we need room for 2 y's. And so with that, we now say this needs an 8 and a y. And this needs an x squared. It has the 8, doesn't have the x squared. There it has the y's. So you end up with 13 times 8, which is, I believe, 104. Yep. Minus 7x to the 4th over whatever your LCM is, which is 8x squared y squared. I think most of these were in your homework, so again, if you understood your homework, you're in decent shape anyway. 9 over d plus 2 minus 4d over all that. Again, the first thing you want to do is make sure you factor anything that can be factored. D plus 2, d minus 2, which means my LCM is that. You then go and say what's missing. This is missing d minus 2. This is missing nothing at all because it's got both, so that turns into 9 times d minus 2 minus 4d over that, which this becomes 9d minus 18, which turns into, what, 5d minus 18 over d plus 2, d minus 2. At any point, I'm sure I'm probably going to mess up something, but at any point, if there is a mistake that I make, feel free to email and let me know so I can inform everybody. If you got an answer or you worked it out and got a different answer and you know that you trust your answer and you don't know where your answer came from, again, send me your work, send me a picture of your work, and let me look at it, and that way I can kind of see what's going on. I did not show you 8, so we're not going to do 8, but that's just a crazy graph that, you know, again, it's more in the specifics area, and I wouldn't have counted that on your test anyway, or if we were in class, we actually would have had time to review it. Graph the function and its asymptotes. Remember, this is the family where the numerator has the higher degree, And so what we do is we ask ourselves, if it was 2 over x squared, what would happen is it would approach 0 on both ends, because again, as x gets bigger, you're making 2 over some huge number, which means that your horizontal asymptote is 0. Our vertical asymptote is at 6. 1, 2, 3, 4, 5, 6. I don't like that, so what I'm going to do is count by 2's. That way I can fit it in the graph. So 2, 4, 6, which puts me here with a vertical asymptote here. And let's see if this actually works out better for me. Again, we understand the shape of this is going to be, it's x squared, so it's probably going to be like this, because remember that flips it around. But other than that, let's check it out and see how it works. Actually, no, it's not 6. You want the value that makes that 0, and so you would actually do x squared minus 6 equals 0, which means x squared equals 6, which means x equals plus or minus root 6. So, almost made a mistake until I realized that I was doing something stupid. So what we're going to do here is approximate square root of 6 and convert that to be let's just say 2.4. So forget about that mentally. Now I am going to count by ones. 2.4, again positive and negative, so 2.4 would be about here. Negative 2.4 would be about here. I still think the edges are going to do what we expect it to do, which is it's going to have that funny shape. We just have to figure out whether it cuts through or whether it turns around. And so for that, we will use our calculator. I'll actually not cheat this time and use the real one. Actually, I don't think I need to. If I plug in negative 2, that makes negative 2 squared, which is 4. 4 minus 6, which is negative 2. 2 over negative 2 is negative 1. If I plug in 2, I get 2 squared, which is 4 minus 6, which is still going to be negative 2, which makes negative 1. If I plug in 1 and negative 1, it should be the same. So 1 would be 1 squared minus 6, which is 5. It'll be negative 2/5, which is a little bit less than half, so about right there. It's going to be the same thing over here, so we can now kind of see the shape, which means 0 should be really close to 0. If I put in 0 2/6, again, feel free to plug that in, but 2/6 is negative 0.3, which is going to be about a third, and so we know that this is going to go something like this. And then again, check a value on both sides of this, and we should be above. So this is 3. If I check 3 here, 1, 2, 3, 3 squared minus 6 is 9. 9 minus 6 is 3, 2/3, so we're going to be somewhere around here. Same thing over there. Negative 3 is also going to make a 9, which means the numbers are going to be almost exact, and your graph is going to look something like this, because remember that your horizontal asymptote is 0. That's what we figured out from this part right there. Number 10 is the one where they give us a family where the numerator wins. And so remember, the first thing you want to do with that is check to see if that goes in, because if it does, remember that's going to be a whole. Numbers that multiply to be 10, add to be 7 are 5 and 2. So let's see, I think it's x minus 5, x minus 2. So what it actually ends up being is, when you divide, first off, there is no horizontal asymptote, but your vertical asymptote, which could be, actually it's not, because remember, if the x minus 5 matches, it's not a vertical asymptote. This is actually a whole at x equals 5. And when you divide, that represents, because there's a whole, or because this matches, this is not, when you divide, it's not your asymptote, it is your line. And so we know that when we divide, we end up with x minus 2, which means we graph x minus 2, which means go down 2, up 1 over 1, draw your line, because again, this would be an asymptote if we did not have a matching factor, but then we have a whole at x equals 5, 1, 2, 3, 4, 5, and so you would add that. So again, that's using an asymptote, but what we learned was that if that matches a factor at the top, it's no longer an asymptote, it's just a whole. We also learned that because that matches, no longer do we have because before, if you remember, we would have a vertical asymptote and this would be dashed and we'd have a graph that looks something like really weird. But again, because that matched, we ended up with a line that has a hole in it, and that would be it. We then did some solving. What we learned when we solved was that even though we find the LCM, we need room for an 8 as well as an x plus 4. Even though we solve, even when we have to use an LCM, we learn that the bottom is unimportant because really it doesn't come into play. And so what you do is you kind of figure out what's needed. That means an 8. This needs an x plus 4. This needs an x plus 4. You end up with 48. Again, I'm ignoring the bottom at this point. Plus 1 times x plus 4 is just going to be x plus 4 equals 7x plus 28. And from there you get 52 plus x equals 7x plus 28. Move your x over, getting 6x equals, that would be 4 more, 34. 34 and 28, no, it'd be 24, because that would make that a 3. So 24, and then when you divide by 6, you get the answer of 4 equals x. And again, you can check that with this calculator. Actually, we can check it with this calculator. I'll show you how. 6. I'm going to put this fraction in parentheses. So parentheses 6 over parentheses 4 plus 4 close plus 1. I'll put this in parentheses also because I don't want anything getting mixed in. So with this calculator, if you want your fractions to be added, subtracted, or manipulated, I'd put them in their own parentheses. So you have 6 over 4 plus 4 in its own group, 1/8 in its own group, and you get this answer. And the way you actually will change this into a fraction is by hitting the math function and then enter, because you want to turn it into a fraction, and enter one more time, and notice you get 7/8, which is what you're supposed to end up with. At some point I would have taught you that, but again, it's the math function. If you ever get to another class and your teacher doesn't show you that, or they think you should know it and you don't know it, just come to me. I'll tell you. I do all that stuff anytime you need. Once your teacher, always your teacher, as long as you are respectful. Now, the people who were mean, which isn't a high amount, I don't know if I'll help them as easily, but again, most of you I will gladly, actually all of you in this class I'll help, because you all have done your job. Again, solve the equation. LCM would be x plus 2, x minus 2. This needs an x minus 2. This needs an x plus 2. This needs nothing. So this turns into 5x minus 10. I'm looking at this negative and making sure I'm careful. And what I would do, if you don't want to mess up with this, is watch this trick. Is I'm going to turn this into a positive, and I'm going to move this negative to the top. That way I know it's negative 3x, and I know it's negative 6, because what some people will do is they'll leave that there and they'll do negative 3, or they'll do minus and then do minus 3x plus 6. But again, that is a negative 3, and all that equals 12. Again, we can ignore the bottom because once we have an LCM, we're good. This turns into 2x minus 16 equals 12. Move your 16, 2x equals 28. And therefore x equals 14. I will use this calculator because it's a little bit easier to plug in to check to see if 14 actually works. 5 over 14 plus 2. I do love how this actually does this. Minus 3 over 14 minus 2 equals, and so we get 1/16. And then what we're going to do is type 12 over 14 squared. I don't need parentheses because this is a good calculator. Minus 4. Cross your fingers. 1/16. Sorry, both of those are 1/16. So here's what I plugged in from the left. Here's what I plugged in from the right. They both equal, which means that we know we did it right. 13 is the one where they're driving at an average speed, taking a certain amount of time, and they want to know how long or whatever the thing was. Remember that the constant here is a distance, and so this is variation problem. So this is where you need to look at it and say, is this directly does it vary directly, does it vary inversely? And so that's where you have to think about your variables here. You have speed and time. And so think about how you're driving. If you drive faster, does that lead to an increase in time or a decrease in time? And common sense says that it should go down, which means that these things are inversely related. So what we would have is speed or time equals k times rate, or something like that. Actually, yeah, we'll just do that. Time equals k times rate, because I don't think it really matters as long as you do it the right way. And so what I would do, again, the easiest way I found to do it when we were doing this was to plug it into the information. You have time would be 23 minutes in the first situation, 37 miles per hour for your rate. On the other one we had 28 minutes for time, and we did not know this rate. And so when you turn this k by itself, remember the easiest way to do this was to get k by itself and set them equal. Not the easiest, but one of the ways. 23 over 37 over here equals k. 28 over r equals k over here. Because both of these are k's, we can connect these two because k is the link. That means that 23 over 37 equals 28 over r, which means that 23r equals whatever 28 times 37 is. I used to know how to do this in my head. I'm ashamed of myself. 1036. And so now you divide by 23 and make sure the answer makes sense. 45. So about 45 minutes. No, 45 miles per hour. That doesn't make sense. 37 miles per hour was 23 minutes. Drive home took 28 minutes. Let's think about this for a second. Time is equal to k times rate. Time was 23. Speed was 37. 23 over 37 is right. Drive home took 28 minutes, which would be your time. And your rate, we don't know. 28 over r, I think that's set up right. Huh, interesting. Because there's no way. The reason I say that is because there is no way that it should be 45 miles per hour if 37 miles per hour led to 23 minutes. If we went faster, we should go down with this, which means, oh, I know what I did wrong. I'm an idiot. Sorry. Hope you didn't follow me too deeply on that. I did a direct variation. But this is why you want to make sure you look at your answer and make sure it makes sense. There is no way going 45 miles per hour is going to add your time. So we should have actually done 23 equals k over 37. We should have actually done 28 equals k over r. There you go. Which means that 23 times 37 equals 851. And over here, 28r equals k. So what we're going to do is 851 equals 28r. So we divide by 28. Which is 30 miles per hour about, which does make much more sense. So again, 30 miles per hour would make sense because, again, if I drove 37 miles per hour and it took me 23 minutes, driving less should make more time. So whew, I survived. Didn't completely screw you up. Thomas can mow his grandfather's lawn in 4 hours. Brother Anthony can do the same work in 3 hours. They decide to work together. How long will it take? This is the work problem where if he can mow a lawn in 4 hours, his rate is 1/4 multiplied by a certain amount of time. He's working with someone, so you're going to add Anthony's rate, which is 1/3, times an amount of time, and they are doing 1 yard, if you remember that. You then need a LCM, which is 12. That means that this needs a 3, that needs a 4, this needs a 12. Keep in mind, again, this is a fraction problem that we're solving, which means that that really does not even come into play. So what you end up with is 3t plus 4t equals 12, because all those would be over 12s anyway. So you end up with 7t equals 12. I think we did this in our example, which means that t is 1. 7 goes into 12 one time with 5 left over. 1 and 5/12 would be it. According to Charles' law, the volume occupied by a gas is directly proportional. Here we go. The volume is directly proportional to its temperature. So volume is directly proportional to temperature. Now that's directly proportional. I know I did it right because I just made my mistake. And then they give me some numbers. They say the volume of a ball is 1.25 at 240 K, which Kelvin is a measure of temperature, so equals K times 240. They want to know what it is when the temperature is 324, so I'm going to put, we don't know the volume, equals K times 324. This turns into 1.25 over 240 equals K. This turns into V over 324 equals K. And from there we set those two things equal to each other, which means we now take 324 times 1.25. I think that should be a whole number. You do get 405 equals 240R. Now you divide that by 240, getting 1.69 R. So again, using your common sense, it's directly proportional, which means this going up should lead to that going up. We had 1.25 liters at 240. 240 went up to 324. 1.25 went up to 1.69. So again, you know you set it up and did it right. But again, just using that common sense check does save you a lot of points, I guess. It won't save you a lot of stress because you just saw how crazy I went on that one when I went the wrong way. Multiple choice questions. Let's zoom out. Let's see if I know how to do that with this new camera. Hey, there it is. Suppose f varies directly as g, f varies inversely as h. This is multiple choice. F varies directly as g, which means it would be k times g, and inversely as h, which means h would go on the bottom. Find g when f equals this and this and this and this. So this is the one where you probably want to this is the one that gives us everything. So in the first one they want to find g when f equals -8, so I'd put a -8 here equals k times, I don't know g, h is 7. On the other one, f is -9, g is 81, h is -3. That means that to get k alone, I'm going to multiply this, which means -56. I'm going to divide by g. Here I'm going to multiply, which makes 27. I'm going to put 81 on the bottom. Again, multiply because it's on the bottom. I'm working to get k alone, so multiply, which is your 27, divide to get 81. Multiply to get -56, divide to get g. That means that these two things are proportional, which means we do 56 times 81, which is -4536 equals 27g, and then we divide that by 27, and we get -168. Again, it should be negative because one of these is negative, which is B. And then the last one, 17, graph the function. We know there should be a, and again they give us 4 options here, so now we can kind of use our common sense. Looking to factor this, the numbers that multiply to be 20 and add to be 9 are x plus 5, x plus 4. That does not match, which means there is a vertical asymptote at -3, which means it can't be this one. And it's -3, which means it shouldn't be this one, because that's going somewhere else. So it's one of these two. And from what I remember, once you know that negative 3 is your asymptote, just plug in a number on the side. So, yeah, that's 2, 3. So plug in a number from the side, so I'm going to plug in 2, and that should give me everything I need. So if I plug in 2, I end up with 2 squared plus 9 times 2 plus 20 equals, divided by 2 plus 3 is 5, which is 8.4. And that is definitely not at 2, going up to 8.4. This 2 looks like it's at, like it wants to get up to 8.4246. Oh, I did negative 2. I'm sorry. Okay, so it's negative 2 is my number. Hold on. Yeah, because negative 3, so I'm trying negative 2. Sorry. Negative 2 squared plus 9 times negative 2 plus 20 equals, divided by, if that's negative 2, that's going to be a 1, which means it should be 6. So that's definitely not hitting 6, whereas this is going 2, 4, 6. Again, what I recognize is that my number was way off. I think I had 8.4, and that was not hitting 8, which means I had made a mistake. So it is that graph. So that represents what you needed to know. Other than that, like I said, enjoy your break. We will be talking Tuesday after break to discuss your last chapter of the book. And again, we might even finish early. Don't get too excited, but we might. Have a good weekend. Have a good break. Talk to you later.